So what we all see out here is heavy rain. It's raining cats and dogs. And I'm gonna collect the velocity of this rain, and I'll just derive the formula. I'm gonna say that okay, I don't know if it's velocity of rain, but it's the volume of rain, the unit area, the unit time. And when I cancel out the unit, it's coming out as meters per second. So that's the velocity I assume. So I'm gonna put this cup in the rain and see the volume it collects over time. Okay, so I'm gonna have a stopwatch running, and I'm going in the rain right now to put the cup. As it starts collecting, I'll start the stopwatch. In fact, as soon as I enter the rain, I'll start the stopwatch. There we go. I'm in the rain, guys. And it's on. We shall see over a few minutes. I shall stop the stopwatch and go collect my water. This is experiment 101. Don't you want to feature? So basically, as I wait, I can just explain the science phenomenon. Okay, I'll collect it in 1 minute's time. So it's 30 seconds. I'm gonna wait for a minute. Collect my cup in 1 minute, but the direction of rain is actually it's not vertical, it's slightly horizontal, but never mind. 80 degrees. No, that's approximately 60 degrees. Yeah, this is actually 60 degrees. How would you know that? I have that protractor. Okay, it's almost time up. I'm going to collect my cup. Okay. In 1 minute. How much water is this? 1 minute. So tell the picture. In 1 minute, how much water have I collected? Okay, the water I've collected is just too small. I guess I should put it on. Okay, this rain is heavier. I'll take the readings of this one instead, and I'll take it as 5 minutes. Okay, up for my second reading. I guess that one wasn't accurate now. Let me do this one. So, okay, so for this one, I'm going to wait for 5 minutes. I know the water is not entering directly inside there, but we can have a unit area of water. Okay, this one I'll take my time. I'll wait for 5 good minutes. 5 good minutes. All right. I was about to get 5 minutes reading, but it seems like the rains have stopped raining. Okay, not really raining. It has come down to cut it. Oh my God! I have to go. Stop. 5 minutes. Done. Okay, so I got my water here for 5 minutes reading. It seems to be so little for such a heavy rain. Alright, so I have, this is the water I collected for a 5 minutes reading. I don't know if you can see cup, but okay, you see that level of water right there, right? That's the one I got for a 5 minutes reading. So I'm gonna measure the volume of this water, divide it by the, what was the unit area? Oh, the unit area at which I was collecting the Nankan. The water is actually the, I'll use it to, it's pi r squared, of course. Okay, the area of the circle of this opening of the cup, that's where, that was the surface area for collecting these rains. Yeah, and I'm gonna do those calculations right now. Yeah, good, that is good. So right now, this is my sample collected from the rain. So I'm measuring its well, I already have the formula. I already created an app for calculating the volume of whatever is in here. So right now I just get the lengths of dimensions I need to calculate the volume. So right now, okay, I'll use a 30 centimeter rule, and of course that's about The reading is okay. What's the reading there? Oh, you're not seeing. Actually, this is 0.4 centimeters. Is it 0.4 centimeters? Oh no, you don't want. This is 0.5 centimeters.
Yeah, exactly.
Okay, yeah. This is 0.5 centimeters. So having the reading here, I can calculate for the volume now. Okay, now we go to the math. Okay, gotta cut the
Christmas.
all right, the measured dimension was 0.5, so you can just go calculate the volume of the water I had, and using that I'm gonna put into the formula and I'll have the calculations. Okay, so to measure the volume, I created a Java program, this one, which I just have to enter the lengths I measured. As you saw there, I was just measuring length. I didn't even get radius, and that's because I already did that. And I can just punch in what I want. So the initial length, it started from 0, and the final is actually 0.5 as I measured. So that gives me the volume. It is 8.97026830772648. Actually, I'll just round off to 2 decimal places, like 8.97. Yeah, that's better. The diameter of this cup is 8.2. The inside diameter of this cup is 8.2. Okay, so I've done the calculations. It's, the volume of rain falling at a specific area in a specific amount of time is as follows. See, the volume of rain I collected was 8.97 centimeters cubed, and the area at which it was falling, it is the diameter of the cup I put in the rain divided by 2 squared. That's like pi r squared. This is like the radius right there. Having done these calculations, this is actually the area at which it was falling, at which the rain was being collected. So if I have the area and volume and time, I can find actually the volume of rain per unit area per unit time. Okay, so there it goes, and I have it. Rain per unit area per unit time is about, okay, it was feeding about 0.03397 on the cup. So that's the volume right there, and it's centimeters per minute. Perhaps we could call it velocity, who knows.